Okay, so due to popular complaint, we need to figure out how to convert to spherical. So, first we should remember how to plot a point in spherical. So, here's an x, y, z, right? Okay, let me kind of hand out coordinates for a point. So here I'm just going to draw a random point here. I'm going to call that x, y, z, right? Yeah. And I'm going to think to myself, all right, if I plotted this in spherical, it'd be a what?
A rho, theta, and a phi.
A rho, a theta, and a phi. Okay, so let me see. Where do I label those?
Well,
phi comes off the z.
Yep. Okay, good. C's off the z, so that's this angle.
Yeah. And then rho is the rate, the length.
And rho's the total length there.
And then theta is from the x.
And theta is the rotation from the x, which is hard to draw here, right?
Just draw a line to that dotted corner. Yeah, like that.
So that's theta, right? Okay, and then there's, let's see, there's an r here too, right?
Yeah.
As distinguished from the rho, right? By the r's the two-dimensional radius and the rho's the three-dimensional radius. So if I was thinking in polar, right? In 2D polar, I'd write r, theta,
Z.
and then z would be the coordinate. So this green thing isn't polar,
It's cylindrical.
it's cylindrical, right? You guys all see that? Okay, so my conversions for cylindrical are relatively easy, right?
Yeah.
You guys see that? They're just the conversions for polar and x and y, and then z is z. Pretty good with that? How about the conversions to spherical? This one might take more thought.
Well, we do know by identity in 2D that x squared plus y squared equals r squared. So then in 3 dimensions, rho can be x squared plus y squared plus z squared.
Awesome. So rho is x squared plus y squared plus z squared. Does this help me convert from x, y, and z to rho's?
No. Well, you're giving the points.
Not really.
No.
So the conversions I'm seeking, right, are x equals, y equals, and z equals.
Okay.
These are the other way, which are perfectly fine, right?
X equals r cos x, y equals r sine.
Okay, so that would be cylindrical.
Okay.
You guys see that? So
Also be
in
cos
spherical,
squared.
I need, okay.
Z is rho cosine phi. That was the easiest one for me to see.
So z, right?
Yeah.
That's that vertical side.
Oh yeah, I see it.
You see
The
that?
angle.
So if I bring that triangle over here, this distance here is still z, right?
Yeah.
And that's the adjacent side to phi.
So it'd be,
And the hypotenuse is rho.
so rho
So
cosine.
z is rho cosine phi. Good? Cool?
Yeah.
Alright. Excellent.
Okay.
How do we find the others?
Well then,
Weird.
rho, no. X is cosine. There's still a cosine theta.
There's
Then-
okay, so
R cosine theta for x, but then could it also be with the sine phi?
alright, so this side here, right? We're saying that's r cosine theta, right? But what's r?
R is all. Oh no. R is it? It's
Rho
not
sine
rho.
theta.
It's
So there's a rho, an r, and a z here, right?
Okay.
You guys see that triangle in there?
Um,
So can I make that triangle help me somehow?
well, the bottom part's theta.
I really want to know what r is in terms of something.
R squared. Well, well, can you use like Pythagoras? No.
Oh, we could do that. That would work.
Really?
That would be inconvenient. It would totally work.
Well, is there a right angle? I'm not sure.
Yeah,
We're
so
making a right angle.
this is a right angle.
Yeah.
Okay.
Why is that a right angle?
It's perpendicular.
Yeah, because the z sticks straight out of the xy plane, right? And r is in the xy plane.
Okay, so then R would equal square root of rho squared minus z squared.
So we could do r squared, right, is, wait, r squared plus z squared? Why am I writing this in different colors? R squared plus z squared is
Rho squared.
rho squared. Okay, I'm liking this actually. This will be good. So
I feel like we're fucked.
that means that r squared plus, what was z?
Z.
Rho
Rho cosine.
Cosine. B.
Okay, so z squared is rho squared, cosine squared, b, right? Equals rho squared.
Okay.
Okay. Uh-huh.
Subtract.
Okay, so subtract. So you get r squared is rho squared times 1 minus cosine squared b.
Oh, that becomes
Sine.
rho squared sine squared.
Yeah, so this is sine squared,
Yeah.
right?
Squared B.
So that reads like r is rho sine b.
B.
Does that make sense?
Yeah.
Yeah. That does, actually.
Oh, you guys see this triangle wasn't the one I wanted? Which triangle was the one I wanted?
The flipped up one with B is the
Yeah.
angle
Right there, yeah.
between rho and Z.
Right, this distance is also r.
What? Oh, okay.
Well, if you just
Yeah, it's like a flag swung around, right?
Mm-hmm.
But of course the top distance, the bottom distance are the same.
Oh.
So of course r is the opposite side from phi with a hypotenuse of rho.
Uh,
That was the coolest. Good. I'm glad you guys were able to sort that out. Now what do I do with that information?
and put that in for R. Oh,
Yeah, x is supposed to be r
R
cosine
theta.
theta,
So now
right?
it's rho sine phi cosine theta.
So I get rho sine phi cos theta. And the y's? Yeah, we can make a triangle. That should be this side. Oops. Did I let you guys screw me up?
Did we?
should just be rho sine phi sine
Sort
theta.
I let you guys screw me up a long time ago. This distance should be
Oh,
rho
the top.
r
Oh yeah.
We
sine.
still wrote it down right.
Should be r cosine.
As far as
Yeah. I was saying it right, but I wrote it down wrong earlier. I indicated the y side and of course wrote the x formula. So what's the y?
R sine theta.
That should be r sine theta, which would be rho sine phi sine theta. Cool. So there's your conversions for spherical. You just cram these in for x, y, and z. And what's the other thing you need?
what dV equals E squared.
Good, you need dv for spherical, which is
R D.
Rho.
Well, a rho.
rho
Rho sine
squared
sine
sine phi
D theta.
d
D.
rho d theta d phi in whatever order.
Okay.
Cool?
Yeah.
Alright, so there's the conversions you need.
Converting to spherical is so much fun.
Yeah, but of course you just memorize this or stick it on your note card or whatever, right? Like,
Substitution.
or go look it up, and then it's just substitution. You just stick this stuff in. Cool? Questions, things?
Then keeping track of what comes out of the constant for each integration.
Yeah, so keeping track of which things are constant with which integration is a nice trick. The other thing that's useful to keep track of is the only other thing you need to remember, which is what?
So I should add to this.
Spheres and stuff.
Remember.
Oh, sine squared theta plus cosine squared theta equals 1. Alright.
Remember, sine squared plus cosine squared is 1. However, it has to be the same something, right? So sine squared of phi plus cosine squared of theta does not do you one bit of good, right? But when you have sine squared of one of them plus cosine squared of the other, you're in good shape. Also, it's worth remembering this thing about rho is x squared plus y squared plus z squared, so that you don't have to do that a bunch of times, right? If you make these substitutions, it is in there, but it will take you a while. Oh, and you let me...
What did I do? I said that, but you just you didn't write it down.
So, remember, rho squared is x squared plus y squared plus z squared.